So you may have heard of patterns like the retry pattern, the throttling pattern, and the circuit breaker pattern. But have you ever heard of the Geode pattern? Well, join me and Will Eastbury today on Cloud with Chris as we talk through the Geode pattern. Hello and welcome back to another episode of Cloud with Chris. You're with me, Chris Reddington, and we'll be talking about all things cloud. Now, as we mentioned in the intro there, we've got another in the series of Architecting for the Cloud one pattern at a time, and I'm delighted to be joined by another of my colleagues today as we go and talk through the Geode pattern today. So without further ado, let's just go ahead and bring him straight into the discussion here. So I'm joined by my colleague and friend, Will Eastbury. So good morning, Will.
Good morning. How are you doing?
All good, thanks. How about yourself?
Yes, I'm good, thank you. All ready and raring to go.
Excellent, excellent. So maybe we should start then jumping straight in and giving a bit of background about yourself and I guess why we're talking about this Geode pattern, because there is a specific reason we've got yourself talking about this one here. Yeah.
Okay, so if I give you a quick background on where the pattern came from, and then we can kind of go on to what it is, how you might use it. The background behind it is some time ago, I was working with a number of businesses around application development and lifecycle, and some raw businesses wanting to build their own services, some ISV and SaaS providers wanting to build services that were distributed that they could white label and sell to others. But the majority of them were working on a transition from building out mainly localized services that were present in one or two data centers, and maybe they were using clustering locally to give high availability. Mm-hmm. And then potentially we were seeing those start to add regional availability. So starting to build that out to, a continental type service or sets of continental services. And they were wanting to add high availability and disaster recovery capabilities to that. A lot of these businesses then wanted to make the next leap to providing a single point of entry, an almost virtual global service. Okay. So wanting to architect services where they could put things into multiple regions and have all of those regions actively serve requests. Because the moment you move to multi-region HA, there's a whole ton of trade-offs and decisions that we have to start to make. So around things like costs, wastage, compute wastage, and Geodes was kind of a pattern that we brought together to start to address how we can trade off some of those usage concerns to get massive performance and latency benefits in a global, planet scale service.
Gotcha. So I'll bring up your screen here for the viewers as well, and I guess this is kind of the again the reason that we're talking about this is this was one of the things that you contributed to in the Azure Architecture Center. So who better to talk about this than literally one of the people who helped put this doc together as well. So I guess the background there was around these planet scale applications and these global applications. So what is the specific problem that I guess we're solving with this one compared to something like, I don't know, deployment stamps, for example? Because on the surface, for anyone listening who knows deployment stamps, they might think, hold on, these two sound quite familiar.
Yeah, they actually are. What the Geode pattern is kind of an evolution of deployment stamps to handle larger scale services where all compute has to be equal. Deployment stamps are a bit more fine-grained in terms of how you might choose to deploy them, and they tend to be tenancy model focused. So you constrain a tenant to a deployment stamp, and that deployment stamp might sit, if you look at what we've got on screen, so that you might have a tenant which is constrained to South America. Yeah, and you might have multiple geodes in South America inside this hosting inside that stamp, or vice versa. Yeah, so you can combine and match the patterns. Whereas the idea behind geodes is I've got multiple geodes that are absolutely identical distributed around the world.
Gotcha.
So anything can serve anything. And my geode in South America actually has the data present to serve services for users that are located in Western Europe. or the vice versa for the US as well. Actually, if I sit here, my request can be served by either this node or this node. Or if this node's offline, we can traverse the Atlantic over to here. Yeah, the only difference should be latency. And then we use the kind of global load balancer services similar to Azure Front Door to get the user's request to where it needs to go in the fastest, lowest latency envelope.
Gotcha. So this is quite interesting then. I guess there's quite a few considerations then for folks who might be looking at this pattern or looking at something like deployment stamps. And one of the obvious contenders is going to be, what are my data sovereignty requirements? Do I have to have my data in one specific region or can it exist anywhere? And that would very quickly maybe not rule out, because I guess that's unfair, because you, as you said earlier, you could have geodes within a region, but the nature of how you're going to deploy at that scale is going to change, right?
Yeah, so I think the key thing when you're talking about deployment stamps, what you're talking about is taking a localized pattern and scaling it up. Yeah, so if I have so much compute that I need to be able to box it down and then kind of build a jigsaw piece together out of smaller pieces to build up a larger platform system where my tenant sits inside a stamp. So Will Eastbury's data is separate from Chris Reddington's data, and Will Eastbury's data goes in stamp 1 and Chris Reddington's data goes in stamp 2. Yeah, and the geographical boundary of that actually doesn't matter. Yeah, your deployment stamp might consist of a set of geodes, but your data wouldn't be present in all stamps. And that's the key definition, yeah. With a geode, or with geodes, Will Eastbury's data is in A and B. And Chris Reddington's data is in A and B. So it does enforce an element of data duplication. Yeah, but there is none. So there is zero compute wastage.
Right.
Yeah, all geodes can scale independently if they need to, and all geodes contain every bit of data.
I get the point you're getting at there. And I guess what the characteristics of this pattern then, which is really interesting, and if we take it to the extreme example here, is let's assume that I work for a certain business, I do a lot of global travel or something like that. In terms of my experience with the application, if I'm traveling from the UK to the US or to Australia, obviously not right now in these times, but if I am traveling around, my experience with the application should be no different no matter where I am, because I've got, wherever I am, a deployment of the application nearby, and it has my data, it has everything that it needs to be self-sufficient effectively. And I think that's the point, is if you've got an application where you've got characteristics like that, where you need that kind of experience, or more importantly, I think the other one's going to be availability and resilience, right?
Exactly. Yeah. So the primary characteristic of this is usually used for performance, but the kind of global HA scenario is a nice side effect, really. It's a nice, interesting feature of the pattern that can make it be used that way. Sure. But because all of the data is present in all regions, or at least slices of the data are present. So if you combine with deployment stamps, you can then have slices of a geode which are present, but that's not necessarily that common in what we see. So to use your example, I don't know if you can see my mouse on the screen.
Yeah, we can.
Yep. Okay, so you're a user that's located in the UK. You have an application that's running. You log in from your phone. Yep, over a 4G connection or 3G connection or 5G if you're very lucky. And you log in here at Heathrow Airport. And you then get on the plane, switch to the plane Wi-Fi on a transit across the Atlantic. Yep, and you land here in New York. And all of a sudden, without any change to your application will switch geode. So instead of connecting back across here for latency, it will be connecting to our global load balance features, and it'll actually connect to the nearest edge endpoint. So it'll actually connect to the nearest orange dot, which will then bridge you into your nearest piece of compute, which in this case will have moved from being there to there. Oh. And because your data has been replicated, your experience will be exactly the same, regardless of where you are.
Gotcha. And I see exactly where you're going, by the way, with the comments around no compute wastage. So let's expand on that, because I think that's like you say, very relevant, especially from a performance standpoint as well. So let's make this maybe a bit more real. And I know you've, along with Christoph in our team as well, have done some example implementations of this pattern for different applications, for example. So let's maybe talk about some of the compute options to that point that would help with that zero compute wastage scenario.
Yeah, that's fair. So let me just scroll this down a little bit into the example architecture that we kind of deployed in the past. So this is a sample implementation that a conference back out in Ireland around state-of-the-art for web applications. And you can see here what we've got. And some people will be familiar with the different iconography, some people will not. So I'll quickly explain what they all are. But these are effectively load balanced endpoints here. These are obviously users. This is AAD, B2C. This is API management, SignalR, Azure Functions, eVault, storage, and Cosmos DB for a replication backplane. So using this collection of services, the key thing here is most of these are built in a serverless/consumption model. So it's no more expensive to serve a request from Geode C than it is to Geode B. Yeah, the effective cost of service is identical. And also, because these are serverless, there are some exceptions to this, and some architectures don't look quite like this because we don't constrain Geode to serverless architectures. But if you deploy everything serverlessly, you can, in theory, deploy Geode A. And this component, this component, this component, and this component are, to all intents and purposes, free. Yeah, so because every request that's served by this Geode is one that's no longer served by this one. So you're just routing traffic to here instead, and then you are just consuming these services instead of these ones. There's a slight difference here with storage and Cosmos because they obviously have a compute cost. We don't have a serverless tier actually for Cosmos, and storage is kind of natively serverless in terms of requests served, but obviously they have a capacity cost. So if you're going to replicate your data to somewhere and it's sitting on disk, there is obviously a cost for that. Yep. So that cost does increase. But generally, within cloud environments, storage is dirt cheap when you compare it to compute.
Makes sense.
There is a nice, elegant pattern, which I think is on screen here. It's actually static content hosting, which also takes advantage of that sometimes. So pre-rendering stuff because compute's expensive and dumping it on storage somewhere actually is something we actually leverage in that demo for using a JavaScript single page front end. But we won't necessarily go through the demo today.
Cool. Makes sense. And I really, really like this example because I think it ticks a number of boxes from an architectural perspective. You know, you've got that side effect of resilience, like we talked about. You've got the performance for users across those different regions and nearby compute, let's say. And then as a result of the type of compute you've chosen in this example, and to your point, completely agree, you don't have to use serverless for the backends, but if you can use these types of technologies, it will make that overall solution a lot more manageable from a cost perspective. I'll word it that way. Because imagine if you did have, you know, you've got 4 geodes right there, but let's assume you've got 8 or 10 geodes because of the number of Azure regions there are. If you're running some kind of compute backend, which is paid per hour, those costs are going to spiral. And, you know, if you think about the scenario of the follow the sun model, this is, in the serverless world, quite literally a follow the sun model. You'll see your costs probably go in line with whatever your users are doing locally, you know, and as your users come online, costs spin up, costs spin down as they go offline. There's, of course, a caveat to that, you know, if one of those regions has an issue, one of the geodes has an issue and it needs to go fail over, then you'll see it light up then. But it's a really nice nuance to the way that's designed as well, and I like that.
Yeah, I mean, depending on what the data is and how lightweight or heavyweight it is, if you've got very, very lightweight geodes that are just kind of hosting metadata for backend services, maybe there's just a user's database somewhere and most of the data is transient. And maybe it's logging to a secondary database, things that it's doing in an event source type model. You can actually spin up geodes on demand. So in that follow the sun model, you might choose to deploy geodes on the fly as the time changes around the globe. Or you might choose to have, for example, in this example, the Cosmos backplane. You might choose to change the RU capacity for each geode to cope with read IO passing through. They'd all probably need to have a backplane amount for write IO for replication traffic, but you might choose to increase and balance out a certain aspect of a given geode because you expect more users to be awake in that region.
I'm with you. So almost, this is getting quite an interesting scenario here, but almost auto-scaling based upon your knowledge of the application. And even if you weren't using a serverless scenario, then you could still manage those costs. And, it's not going to be zero cost like serverless would be or could be, but it's correct. At least manageable. And I think that's interesting. And I think it's important for us to call out here. I think that's a good aim and a good objective for people, but that kind of scenario is going to take a lot of operational maturity, understanding what the nature is of my application across those different regions and what the scale is and all those different kind of caveats. And sometimes we don't see people knowing that type of detail about their application or to the detail that's needed. So that would be maybe one caveat with that approach, I think.
Yeah, I guess the thing to keep in mind around that specific point is the idea behind a geode is it doesn't have dependencies outside of the geode footprint. So sometimes there are backplane connections. So obviously front door is not inside your geode. Yeah. And although we represent this as the Cosmos endpoint being here, technically Cosmos isn't inside your geode either. Yeah, so those two pieces notwithstanding that have connections which are illustrated on the diagram outside of the geode, all of the components inside the geode are self-contained. Yeah, if you lose an AppIm instance at the front of Geode C, Geode C goes offline until you can recover it, and A, B, and D should take over and continue. And they can auto-scale out independently because they will have their own auto-scale settings and metrics and rules applied. They may not all scale out. I guess it depends on which POPs happen to be closest to the other users then, so to European users. So you might have two European geodes as well. In practice, you might have a Western and North European geode. But the idea behind the granular scale out is the geode's pattern scales at the geode level, not globally.
Yep.
So it's very, very fine-grained and very, very far-flung, but you can aggregate these up individually. So if you're looking at a metrics graph, which is saying how many requests do I see coming in, and you're doing that through Azure Monitor, say, the number of requests coming in through, let's say Cosmos, for example. What you'd be looking at is a graph with 4 lines on it, which are all stacked on top of each other.
Yes.
So RU's consumed versus RU capacity. Rather than looking at the one geode individually, you manage and monitor geodes collectively.
Yep.
Because they are part of the same distributed system.
Gotcha. No, it makes sense. And as you were explaining that, there was another thing that popped into my mind as well, and I see it as the first bullet point underneath the diagram there. If you are building a system like this, and you kind of touched upon it earlier as well, being able to deploy dynamically, you're not going to be able to do something like this manually. That's just, again, operationally, it's going to be very hard, if not impossible, to go and do that in a manual way. So automating that deployment is probably something you'd look at in this scenario.
So one of the things that we found when we were building out one of the demonstrations for the first implementation of this is you have to template this. Right. Yeah. And I think what we're saying here on the screen, if you look at this, is saying often defined in a template. Yeah. So it's not mandatory. You can do geos without it, but actually it is very complicated. Yes. And the settings which get provided within the geographical elements relate to each other, not to the geode collection as a whole. Yeah, so this AppIm instance is pointing at this functions instance, which is pointing at this key vault, which is pointing at this Signal R instance and this storage account. Yeah. The only bits which are global are Cosmos and the front door, which can represent each one. So the management, when you add a geode, needs to deploy the geode, add the Cosmos region, and then add a front door backplane, but only when it's ready. Yes. So it can only come online when the platform is complete. And managing that is a key bit of complication around, okay, well, when would this scale out? What's going to happen with the other regions? How do I actually online a geode? And what's required to be present? Because you can configure this. You can add if I add Geode E, yeah, and let's say that goes in UK South in Azure, and I add the Cosmos endpoint, well, it's perfectly valid for Geode E to have its own defined compute resources, but for it to connect to the European endpoint for Cosmos until the UK South one has been, cloned and copied and replicated and is online. And that would result in you seeing some additional stress for the European request units. And if you've got enough buffer capacity, that's fine. If you haven't, you then need to scale the European Cosmos endpoint individually, which is really challenging. So interactions between geodes are best avoided.
Gotcha. And I know this is kind of a conversation we've had before, so let's jump and add this in as well. I know that when you were putting this document together, one of the things that you did is you actually showed this to the team who kind of own this area and own this site, and something with the demo inadvertently went wrong, but proved the point, right, of what we're talking about here. So do you want to expand on that one a little bit?
Yeah, I don't know if I hang my head in shame, but basically we misconfigured one of the regions. So a configuration flaw in our functions endpoint for Europe. Sorry, for UK, for US West. Meant that our users in Seattle were actually connecting to Western Europe without us knowing about it in the live demonstration that we were doing. So when we, as part of the demonstration, we rip out a geode, because that's the whole point of this, is that you can just kill one or more at random, and the platform should stay running in terms of, ultra HA. So we pulled one, and when we looked at the traffic routing, we found that of our 4 geodes, only 2 of them were currently online. And the reason for that was because the American geode was misconfigured. So it was sending back failed health probes back to Cosmos, and we hadn't noticed in terms of our capacity planning, in terms of the testing that we were doing, because the other geodes had just scaled to meet demand. So we actually pulled a second node out, and the platform continued to operate completely transparency with 50% capacity. Yep. And then, just for the hell of it, just to push the edge of the envelope, we pulled a third. So we let it drop to 25% of the previously provisioned, architectural capacity, and the platform just scaled out again to meet demand. Yep. We saw a little bit of pressure on the data backplane in a single region, but actually what we were doing wasn't that heavy for the demo. Yeah. In a very, very write-heavy system, that might have been a challenge to run at 25% of the scale capacity. Sure. But by and large, what was happening was the system just stayed up and just the other components just scaled out because they were serverless.
And I think what that demonstrates is 2 points that we've been talking about, is this idea that the primary idea behind this pattern is to do with performance, and you didn't lose any performance whilst you pulled those away. Yeah. And the importance of templating as well is, even the best of us, right? We make mistakes. We're all human. We all get things wrong. Yeah. And, it just so happens that actually that pattern helped almost mask that problem in a positive way. And you would have picked that up with the right operational practices and monitoring pieces in the back end. But for the demo purposes, it actually solved, or rather proved, that quite nicely as well, which is a nice side effect to that mistake.
Yeah, well, it was one of those interesting ones. It was, okay, so you should have just seen, speaking to people on the other side of the globe, you should have just seen your display change when your platform's the clients automatically reconnected from US West to West Europe. You should have just seen that, and they're like, no. Okay, so what does it show? It shows Australia East. Oh, okay. So we're now routing traffic dynamically to Australia, are we? Okay. And it just shows that you don't intervene in traffic control. That's the other thing. That traffic flow is optimized based upon the edge network.
Yes.
And you actually explicitly don't want control. Yeah, so it's almost the opposite of a sovereignty pattern.
Yes.
Yeah, it's like, I can route this anywhere because we have dynamic network and edge acceleration technologies that will just do that for me.
And I think we're naturally moving into some of the issues and considerations here with that point. But I guess that is one of the main things, is if you are looking to control where you route your users, this is not really the pattern for you. What you're looking in this type of pattern is, I don't care where I go, I just need to keep processing and keep the application going, really.
Yeah, I mean, Geodes you can use the availability aspects to keep certain regions up, and it's a similar pattern that is closer to deployment stamps if you do this. So we've had one customer very recently come to us and say they want to do something very similar to this with Traffic Manager and multiple deployed instances that are identical, potentially using data sync across to keep their instances synchronized, because they have a legacy architecture that's based on storage, based on SQL. So they want to have multiple disparate stores with a Geode pattern in front, and then use sync to keep those in sync, literally. But what they needed was those synchronized stores to be localized. So a sub collection of geodes, maybe, in fact, let's take the screen. So let's say you had 7 or 8 geodes, but 3 of those geodes have to contain the data for a given user. So a sub stamp, so to speak. And in that case, if you want to route users to those endpoints only, the trick is to have a stack of multiple geodes and put Traffic Manager in between in a geographic mode. So actually you end up with a regional geode, geode stamp, which is a slice of your big geodes, where your storage only is different between the different regions, but the compute is configured identically.
And there's even, as you were explaining that, there's another customer we've paired up on, actually, where they are going to be using both this pattern as well as the deployment stamps pattern. So the deployment stamps for the back end, because they've got, sensitive end user information, which is protected under, data sovereignty rules of various kinds. And then for the actual configuration of the applications at a global level and some of the more management nature, let's say, they've then gone ahead and used the Geode pattern to make sure that's deployed across all of the regions consistently then as well. So I think that's the other important point, isn't it? It's not a case of either or. It could be both.
Absolutely.
And it just depends on the scenario.
It's actually really, really elegant to do it that way as well. So if you have a situation where you're a big multi-tenant software as a service provider, or you want to become a big multi-tenant software as a service provider, just using the edge routing backplane, so using front door to add a ton of domains for each tenant, and then ingressing into your different multiple geode points the original tenant name as a header. So in this case, actually, front door will forward it as the forwarded for header. Then traffic from multiple tenants can hit a common set of geodes, and you can filter and act accordingly and authorize and validate what you want to validate. But you only deploy one geode in each region. Or if you want stamps, you do that and you deploy each tenant being routed to a given stack of geodes. But look, after you.
No, I was just going to say, and that's where then you could go ahead and even using things like that forwarded header, you could have your own custom routing logic if you really needed that level of complexity as part of that geode deployment, and some database or data plane that you go and manage where your different tenants are located. So there's n number of levels that you could take this. Like anything, it always comes back to those requirements and what's the least complex way that you can achieve what you need to go and achieve, I think, is really what we'd be advocating for there, isn't it?
Yeah, that's absolutely right. And the way you can achieve what we just described, if we take the Cosmos aspect here, and instead of locating that inside a geode, separate the data source out into a deployment stamp behind your compute geodes. So if we bring Cosmos down to here, and maybe we've got 20 Cosmos instances, Yeah, and they're all hitting a single backplane, but we've got multiple replication backplanes for the Cosmos instances. So my user in Sydney, regardless of which tenant they're on or which deployment stamp they're in, follows the same path to hit the APAC geode. When we come in via AppIm and functions in here, or whatever compute layer you're doing, we know because of the tenant ID on the header that was forwarded into here, which tenant my user is in. And therefore, we've got a mapping which says, go hit this Cosmos collection, or this Cosmos collection, or this Cosmos collection. Yep. And in that case, that's actually hitting a back-end storage deployment stamp, which could still be Cosmos, or it could be SQL, or it could be whatever. But that's different based on the header that's specified for the tenant. So they hit a different database in here. And in that scenario, that's a really elegant way of like uber high density hosting, where you just have one set of compute in each region for HA and for localization coming in across a common front end. So you've got nice connection management, but you've got a different set of geographically managed data services at the back end. So my Asia Pacific data never leaves the Asia Pacific data stamp. But in theory, if APAC's compute is down, so if functions is down in the Australia region, for example, I can transiently connect to the United States and then transit that backplane. So you lose a little bit in terms of latency, but the majority of there's kind of two hops for latency, right? You've got end user to the front, and then we've got from the compute to the data store. Yep. So you can still optimize this where you need to. Equally, you might have a pair of these, right? Yeah. You might have one on either side of Australia.
And I think degradation is better than no application, right? So, the fact that you've still got it going, even with a bit of latency, is still good. Makes sense.
Yeah, well, I guess it depends on what the application is.
Of course, yeah, of course.
This won't necessarily work for absolutely every application, which we talked about in the past. But the idea, this works really well with greenfield apps that can be architected and designed this way. It can be a real challenge to retrofit.
Yes, and we've seen that as well, right, with customers where they've wanted to go and add HA and, try and deploy across two regions within a geo. And because the changing of the code of their application is a non-starter, it's just not possible, they have to be creative then, because that is a fixed requirement that they have to have at that point. And, they might re-architect in the future, but it's just something at that point they can't do. And when they've done their proof of concept, the latency is just too high because of the way that typically we see, right, legacy applications don't optimize their database calls because they never needed to on-prem. It's all right next to each other. And what you find in the cloud is that 1 meter sprint suddenly becomes 100 meter sprint, and you've got to do 500 of them. And, suddenly that problem grows very quickly. And that's what we've seen a few times.
Yeah. You have to have that multi-write backplane as well to be able to do this. That's critical. So you have to have some way of replicating data changes on the fly to writable stores, or have a backplane that's capable of replicating the write itself. Yeah. So where Cosmos, you can hit a single connection string and the platform will figure out which writable node and readable node you're going to go to. That makes this ideal. Whereas with SQL, if you can have 4 replicas, but only one of them is writable. So if my European node is writable and the others are only readable and I need 2 connection strings to fail over, that isn't Geodes, because not all of the Geodes are identical. One of them is a master.
Yes.
Yeah, and that master then brings in additional complexity. So if I can't write to all of them, or the platform doesn't figure out which one needs to be written regardless of which Geode I'm on, if it's not client code based, that begins to move away from the core tenets of what this pattern is designed to do.
Makes sense.
And then you're into leader election, for example. How do I elect the master?
Yes.
Yeah, and that's incredibly complex in geo-distributed systems.
Yep.
But as a sneak preview, we may have something being added as an address around that particular challenge around a kind of geo-distributed quorum in the future.
Excellent. So stay tuned for that one. I'm sure you'll be revisiting us as and when that becomes available there. Good. Yeah. So I guess then we've covered I guess, a lot of the considerations and some of the issues there as well. And I think even some of the scenarios when to use the pattern and when you might not want to use that pattern as well. So is there anything that we haven't necessarily covered that you wanted us to dive into as well here, Will? Or do you think that's a good ground there?
I think we've covered most of the core tenets. The one thing we didn't really cover is where it's almost what the feature that it leverages in a core pattern. So if you think about what happens with a number of big data type scenarios and something like a MapReduce or Hadoop type tactic, this is almost that in reverse. Yeah, so we are distributing compute across multiple nodes, and we're actually using the load balancing features to distribute request processing in that way, rather than how MapReduce takes one big request and distributes components of it. What we're really doing is like a super advanced load balancing technique here, and it is absolutely reliant on the ability of your front end load balancers and your back-end data planes. So you need to choose those very, very wisely to support the number of geodes and the type of geodes that you're going to have. But this isn't, you look at this and this is like, wow, this is really different to what people are doing. Yeah. And actually, if you take those two features away, it's not that different to a 4-node cluster. It's just those 4 nodes aren't what we define as a node becomes a geode. And that's the pattern title. It's a geographical node.
Gotcha.
So we just take a clustering methodology in a shared nothing architecture, take that and split it onto different continents. And that's how we begin to build out an architecture that looks like this. We've seen a lot of variants on this as well. This is one particular one that we thought was easy to demonstrate and easy to illustrate in this way. But there are other architectures. SignalR is very specific to real-time web. So because we were demonstrating a voting application, that's why we use SignalR. But there's one particular feature around the use of SignalR and Cosmos in here, which is worth talking about because it enables stuff that you currently can't do with any other architecture without massive complexity. So one of the really, really important features in here, in this particular design, which we kind of undersing a little bit, is the use of the change feed from Cosmos to replay changes that were made in one region in others. So my Sydney user, pushes something in through Appim, gets written in functions, gets written to the Cosmos database. In the other geodes, well, in fact, in all geodes, because they're all identical, it will actually read back in Geode as well. We're listening to the change feed for Cosmos, and there's a feature in Cosmos called the least collection, and there's a feature in that called a prefix, which you can vary. So if you vary the least collection prefix for the reader in here, you can have a multiple read. So every single geode gets notified about every change to the collection and can perform an action on it. So, and we're using this in the voting application to notify other regions of the voting which is happening. So you could build out a chat application like this. You could actually quite easily do that, and you wouldn't have a common SignalR backplane. You'd have a geo-distributed chat application where we actually, there was a slight delay on that as you see propagation. But anything where data is aggregated across multiple locations is really useful there. So voting kind of made sense as a simple example.
And I guess the nice...
But
equally,
there's the opposite of that feature. So in some cases, you only want a vote to be counted once inside a region. So we can also make the least collection prefix the same across all of the geodes. And if we do that, because it's just a configuration setting, we connect into that, and what will happen is each geode will try and lock a partition or a range of partitions in that Cosmos DB to process. So each region will process a subset of the feed, and it means that each entity in the feed will only ever be processed once in one region. So you can maintain aggregations which and they're not duplicated. So you effectively, if you have very small geodes that only have one partition, then you end up with a singleton. Yeah, but the configuration of your geode is dynamic because they'll try and take a lease out on each partition. We know that each partition is only going to have one reader in that context. And that's a choice that we can make by varying that. We can either say, I want all regions to process all data inbound, and they can maintain their own aggregates or their own notifications or their own mail shots or whatever you want to do. Or I can say, actually, I want each collection to lock part of the global whole and ensure that we only process things once.
Yeah, makes sense. And I think the nice thing as well, just to really call it out for anyone listening or watching here, is some of the magic behind that as well. You mentioned about Signal R as the example and referencing the change feed. Both of those are things that you can bind to with Azure Functions. So coming back to that serverless world, you could realistically have an Azure function which is just watching the change feed and coming back to your polling scenario. As it sees there are more votes, it then goes and updates that Signal R binding to reference the new data and present that aggregated view, probably a materialized view of some sort, rather than each event coming in. But that's the kind of power you can see when you start combining some of these different patterns and some of these different techniques here as well.
Yeah, I mean, maybe on a follow-up, I don't think we've got time today, but maybe on a follow-up, we could get the gentleman that actually put the demonstration together to jump on alongside us and actually spin that through. Because I wouldn't want to take credit for the actual demo he put together around this, because it is brilliant. So what that is actually doing, it's connecting out to the Signal R namespace from a given user and subscribes for notifications from that geode.
Yeah, let's do that.
So you basically end up with that partitioned route where you do a vote. Somebody can vote in South Africa. It comes in across the backplane. The functions binding for for Cosmos change feed lights up, and then uses the output binding for Signal R to replay the message of that somebody voted in another country back to them. And then there's an event source pattern around how we actually store that as well. So it's a nice combination, but we should get Christoph to
for sure
jump on with
Excellent. No, we can do that. Good. No, really good session there, Will. So I guess as we start kind of closing out and wrapping up here, is there anything that we just want to highlight specifically and just really point towards as not call to action, but just to really emphasize what we've talked about here today?
So the key parts for me are, and we've touched on these already. So use of intelligent edge networks. Yeah, you can start to see some of these things evolving in 5G around kind of very, very small, tiny geodes in roadside cabinets and on intelligent edge processing. That's a classic example of this, just on a very, very devolved scale. I've got 1 million geodes. They're impossible to manage unless they're all the same, even at the hardware level, potentially at that point. So that's one of the things you'll start to see there, and they all have to maintain configuration from somewhere. So that configuration database could be a completely different service. It could be IoT Edge or IoT DPS, device provisioning service, for example. So the pattern applies across a very wide gamut of services. And the last thought I think to leave with to close out from my pattern perspective is this is designed where active passive processing is too expensive. Yeah, so where you've got very, very big services and you need to make the max use of the resource you've got, or you want to dynamically scale up and down, this is active, rather than just active passive. So this is anywhere where you're architecting a system where you need to be thinking about a cluster. If you want it to be more effective, more performant, and more resilient, consider this pattern.
Excellent. Great. Well, Will, really, really good session there. Thank you for coming onto the show today, and thank you for talking about it. I think, for anyone who's building those brand new applications, and they've got these kind of scenarios where they've got either global user base or a desire to be as performant as some of the characteristics we've discussed here. I think this is certainly something they'll be looking at. Excellent.
Fabulous.
Great. Well, thank you for joining us and giving a great session here, Will.
No, pleasure. Look forward to speaking to you again.
Thank you. So that was the Geode pattern. So as we mentioned, very high performing applications, and a side effect of those would be the idea that you can get this globally distributed application here as well. Some really interesting patterns there, and looking at how cloud applications are really evolving over time, and some of these new technologies are influencing some of these patterns here. So this is another of the episodes of Architecting in Cloud, one pattern at a time. If you have enjoyed the content, please do like, please do subscribe, and more importantly, please do share it on, because we want to make sure that people are using this content and being able to go ahead and leverage this and have it be valuable, really. So do share this on, and of course, any requests, any questions, do get in touch. We're always happy to take those separately as well. So it sounds like we'll get Will back again to talk about some other patterns, and I'm sure we'll look at the little more hands-on example with Christoph as well at a later point. So until then, all there is to say is thank you for watching, and until next time, bye for now.